A modern household is highly dependent on electricity. But the only feedback a house owner gets about their electricity usage is at the end of the month, in the form of an electricity bill. But this bill does not give feedback on which devices consumed how much power. Hence, a user cannot come to a solid conclusion about which devices to use less, which devices to upgrade, and which devices to use during non-peak hours. This is the motivation behind our project. By providing the user with real-time feedback about their energy consumption, electricity wastage can be reduced. Load monitoring is monitoring the power usage of separate devices used in a household. This can be done in two main ways, the first being intrusive load monitoring. Here, electrical device is monitored using a dedicated smart plug attached to the device. This method is expensive and troublesome to set up. The second method is non-intrusive load monitoring. Here, the total power consumption signal of the house is captured and this signal is used to infer appliance-specific power consumptions. We focused on the second method. For our disaggregation algorithm, we use dedicated models to extract appliance-specific signatures from the aggregate power signal. For example, here you can observe the signature of a washing machine, which consists of a heating cycle and several spin cycles. You can observe how the model accurately predicts the power consumption of the washing machine, even in the presence of other devices. Specific signatures like this are available in most electrical devices. Let's look at a demonstration of our project. On the top left, you can see the three appliances we used, a fridge, a microwave, and a kettle. You can also see the inferred power consumption curves of the devices. Notice how, when we open the door of the refrigerator, the total power graph and the fridge's graph both show a sudden increase. This is because the compressor of the fridge is turned on when the door is opened. Now the kettle is switched on along with the refrigerator. Notice how both the fridge and the kettle are correctly inferred during this period. The kettle now turns off and a correct inference is made. Now the microwave is turned on for 2 minutes. Notice how the consumption of the fridge is still correctly inferred along with the microwave. Now the fridge is turned off and you can see the fridge's graph and the total power graph reflects this appropriately. As you observed, we were capable of developing a non-intrusive load monitoring system with real-time capability. The accuracy of our system is higher than existing state-of-the-art systems. To summarize our project, we were able to develop a working system complete with an accurate power monitor, a smooth data pipeline, cloud disaggregation using deep learning models, and finally, a user-friendly web application. We believe that this project can be further improved to make a significant contribution towards electricity saving in a household.